All right, here we go. Last one, 4.7, the law of sines and the law of cosine. So both of these laws are used for an oblique triangle. All that means is that they're not right. So something's wrong about them because they're not right. No, just kidding. They're oblique. They're not a right triangle. So anything but a right triangle. Actually, they will work on right triangles too, but you don't need them on a right triangle because you have a SOHCAHTOA. So the next concept is the law of sines. So the law of sines you can use if you have angle, angle, side, angle, or side, side, angle. And if you read this one backwards, remember that's something that you should never use for similar triangles. But side, side works. Sorry, law of sines works. And so what you're looking at here, you have your angle and your side. And I always look at it as the angle side pairs here. And all this is telling you is that if you have at least one complete pair and part of another pair, then you can use the law of sines. So it's sine of the angle over the side equals sine of the angle over the side equals sine of the angle over the side. So you pick any two out of those that you want. So I picked A and B because maybe I knew all of the A parts and one part of the B. So as long as you have a complete angle side pair, then law of sines works. So I've already set these up for you. This is applying the law of sines on angle, angle, side. And if I look at this, we're going to solve the triangles, round sides to the nearest tenth and angles to the nearest degree. So you can find this angle anyway. It is 66 degrees because it's 180 minus 51 minus 63. And that's 66. So now I'm going to go ahead and erase that. Put 66 in here. Now I have a complete pair. I have a complete pair in R. So what I need to do is I set up the sine of 63 over 13 equals, and this first one I'm going to find side S. So I have sine of 51 over S. I'm going to cross multiply and divide. So S sine of 63 equals 13 sine of 51. Divide by sine of 63 because it's just a number. And I get S is equal to 11.3, so to the nearest tenth. Now, be careful. I have sine of 51, so is that a radian or a degree? That's a degree, so make sure that your calculator is in degrees when you do this. So again, cross multiply and divide. I'm going to go ahead and 13 sine of 66 divided by sine of 63. That gives me side T is equal to 13.3. Now let's check to make sure this makes sense, because you learned in geometry that the largest angle and longest side are opposite of each other. So 66 was my largest, so side T should have been the longest, and it was 13.3, so that makes sense. And then I go and I look, then my smallest is S, and my smallest side is 11.3. Yes, it's S. So we have one situation when we have a side-side angle, and it's called the ambiguous case. And in this situation, you could have one, two, or no solutions. So what's going on is that and this is why you cannot prove that triangles were congruent using angle side side or side side angle, because of this situation. So we have an angle, a side, and a side. And so this angle and this side are set. And this side right here, it could have been to where it wasn't even long enough to reach. So that would be no solution. Now, you don't have to worry about no solution because your calculator is going to let you know if there's no solution. The next situation is your angle is set, your side is set, and then this the second side right here, it could be just perfect enough to where it only hits at one time. And so there'll only be one solution. The next scenario is your angle is set, this side is set, and then this second side right here, because we don't know the length of this one, is that it could have been long enough to swing out this way or swing in this way. And so let's look at one of those. So let's look at what's going on with it. We have this triangle, and we have our two sides A and B, and our angle A. So this first part's for an acute, when angle A is less than 90. And sine of A is equal to H over B, so H is equal to B sine of A. So when we're talking about H is equal to the B times the sine of A. So first case is that if A is less than B and then A is also less than H, then there is no solution, so you don't have to worry about it because H is that length right here. Now next case, if A is less than B but A is equal to H, there's going to be one solution. If A is less than B, notice each of these less than B, less than B, less than B. But this time A is greater than H. It's longer than this right here. It's going to swing and hit it twice. And the next situation is when A is greater than or equal to B. And if that's the case, there's only one solution. So here, less than, less than, less than. And then you have to figure out what H is, which is B sine of A. And then compare A to that H that we get. If it's less than H, don't worry about it because it's not long enough to touch. If it's equal to H, it will only touch it one time. If it's greater than H, it's going to touch it twice. So it'll like be a pendulum. It'll go below the line and come back and touch it. So it could have been two different triangles. And of course, if it's greater than or equal to B, you don't have to worry about it because there's only one solution anyway. And that's all for acute. Obtuse is a little, and right are a little easier. If A is less than or equal to B, if this is a right or obtuse angle, then there's no solution. Don't worry about it. And if A is greater than B, there's only one solution. So really, if it's an obtuse angle, you're good. You're golden. It's either not going to work or it works. Okay, so let's look at these scenarios. So for the first one, angle A, that is acute. So we could have one, no, or two solutions. So we need to figure out what H is. So first of all, here's A, and A is less than H. So we have possibility still going on. And then H is equal to 25 sine of 63, which gives me 22.3. 22.3, that is greater than 18. And because H is longer than A, that means H is how far it would take to touch down here. This is H. It's going to take 22.3 for this side to reach, and it only goes 18, so it means there is no solution. Next one, B, this is an obtuse angle, and because it's obtuse, it's either going to be one or none. So I don't have to worry about the two solution scenario. So I have A, B, and C. And now A is 105, and then A is 73, B is 55, and I don't know C. So I've got to find all of these. So I'm going to set up my law of sines, and I see my angle side pair. So sine of 105 over 73 equals, and I'm going to go ahead and find B, angle B, because I can't find angle C without knowing angle B. So I have sine of B over 55. Cross multiply, sine of B equals 55 sine of 105 divided by 73. So sine B equals 0.7278, and then I do B is equal to the inverse sine, or arc sine, remember that, 7278, and I get that B is equal to 47 degrees. Now I can do angle C, because it's 180 minus 105 minus 47, because there's 180 degrees in a triangle, and I get 28 degrees. Now I set up my law of sines again for side C. So sine of 105 over 73 equals sine of 28 over C, and turns out that C is equal to 35.5. Again, longest side, largest angle, shortest side, smallest angle. Alright, so this one straight up tells us that there's going to be two triangles, but we're going to say that you didn't know that to begin with. And here's A, B, and C. So go ahead and kind of draw it. Now you can put C anywhere you want to. So we're going to treat it like it's the B side. But here, 45 here, 18, and then C length is 24. So C, this is B, and here's A. And that 24 looks like a 29. It's a 4. Okay. Knowing that it's going to have two, I'm going to go ahead and set up two sections to fill in. So A, B, C. I'll call this B1, and then A, B, C, and B1 again. So A is going to be, and of course this is C1. C is going to change here, and it will not change. So 24, 18, 45. And then I'll go ahead and write it over here to the side. A. These are set. B2, B2, C, and C2. Now, if I did not know, I would go ahead and say, okay, well, A is less than C, so there could be 1, 2, or none. And let's just check. H is equal to 24 sine of 45, so that's 16.9. So that means that it takes 16.9 to reach the side, but there's 18, so there's enough to swing back. Now let me show you something before we go on. If I take this 18 right here, this is 18 and this is 18, it's an isosceles triangle. So that means that this angle and this angle are congruent. And I'm going to show you what that means for us in a second. But keep that in mind, it's isosceles. So first thing I need to do is find C1. So I'm going to set it up. And so sine of 45 over 18 equals sine of C over 24, which solving that gives me C is 71 degrees. So this is 71 here. This is also 71 here. And in order to find the second C, what I need to do is that this makes a line right here. So 180 minus 71 gives me the second C. So that's 109 degrees. So C2 is 109 degrees. And that's how we're going to get our second triangle. Now it's easy to find B because there's 180 degrees in a triangle. So 180 minus 71 minus 45, that's 64 for this one. And then for B2 on the other one, 180 minus 109 minus 45, that's 26 degrees. So what you need to realize is that when you solve it in your calculator, it will always give you the acute angle. It will not give you the obtuse. And you'll have to take 180 right here minus the C that it gives you to get the second C. Alright, now we find this last B's by setting them up. So, first one, sine of 45 over 18 equals sine 64 over B1. Solving that, B1 equals 22.9. So 22.9. And then setting up the other one, sine of 45 over 18 equals sine of 26 over B2. So B2, that's not B squared. Oh my, that looks like a squared. B sub 2 is equal to 11.2. Now let's look at the law of cosines. And the law of cosines starts out as the Pythagorean theorem, a squared equals b squared plus c squared, but it is not a right triangle, and so we have to adjust for it. And so it is minus 2BC, so whatever the letters are here, 2 times the BC cosine of the angle opposite the side you started with. Now, this is used for side angle side, or this is used for when you do not have a complete pair. Okay, this is also used for side, side, side. So you don't have a complete angle side pair. So side, angle, side, no complete pair. Or side, 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 no complete pair. Alright, so let's walk you through this. A triangular area of lawn has a sprinkler located at each vertex. If the sides of a lawn are 19, 24.3, and 21.8, so 19, 24.3, 21.8, what angle should each sprinkler be set to cover? Okay, so maybe I should have set this up. So it's 21.8 squared equals 24.3 squared plus 19 squared minus 2 times 24.3 times 19 cosine of C. It doesn't matter which one you started with, I picked the cosine of C. So be careful. All of this right here is multiplied by the cosine of C. So you do not take and put in your calculator 24.3 squared plus 19 squared minus 2 times 24.3 times 19 and hit enter and get a number in front of the cosine. Do not do that. You've got to move these two over to the other side, which is what happened here, subtracted them, and then divide by whatever is in front of the cosine of C. And that gives me this decimal. Take the inverse cosine and I get 59 degrees. So C is 59 degrees. And then I set up law of sines. You don't ever do law of cosines twice. Do law of cosines once, and then the second time you'll set up a law of sines. Solve this for angle B, and I get 73 degrees, and then 180 minus 59 minus 73 gives me 48 degrees for angle A. Next setup, solving the triangle. I'm given side, angle, side, no complete pair. I have to use the law of cosines to start with. And this one's easier. I want side C. That's the side I have to start with, so I'll have a complete pair. So C squared equals 5 squared plus 8 squared minus 2 times 5 times 8 cosine of 65. Put it all in your calculator, you get C at 7.4. Set up law of sines. Could have picked either angle to set up, and I get B is 78 degrees. And then 180 minus 65 minus 78 is 37 degrees. Alright, here's a new formula for you, and this is really neat. This is Heron's formula. You can find the area of any triangle if you know the 3 side lengths. So any triangle you desire, if you know the 3 side lengths, you can find it. So you don't have to worry about, is it a right triangle? You've got it. So what we do is we take the square root of S, which is the semi-perimeter, which is half the perimeter. So you'd add up those 3 sides, A, B, and C, A plus B plus C, and divide it by 2. That's S. You take S times S minus A times S minus B times S minus C, and take the square root of all of this in here, and that's your area. So here we go. If we have a triangle and we want to find the area, and it has a side length of 24, 53, and 39. So 39 plus 24 plus 53 divided by 2, that's 58. And then we take the square root of 58 times, and it's going to be 58 minus 39 is 19, 58 minus 24 is 34, and 58 minus 53 is 5. Boom, hitting the calculator. It's 432.8 centimeters squared. Don't forget your units, okay? One more way to find the area. Now, don't you wish you knew all of these, a long time ago? But sorry, you didn't. Now you do. You can also find the area if you know side, angle, side in an oblique triangle. Remember oblique? It's just not right. So we're going to take 1/2 BC sine of A Notice if it's B and C, we use the other angle because it's side angle side. So AC sine of B, AB sine of C. So here's the last page. We're going to find the area of triangle ABC to the nearest tenth. So I have side, angle, side. So I'm going to take 1/2. Don't forget the half. A lot of people forget it. The two sides, 52 times 39 times the sine of 25.89. Punch in the calculator, 442.8 inches squared. That's it. Hope you got all those formulas down.